All right, welcome everybody. In this video, I want to talk about how we implement a bootstrapping and construct a bootstrap distribution in practice in R. And we're going to use a for loop down the line. But before we get there, I want to just talk about like how many bootstrap resamples we have and how many times we're going to need to run a for loop to construct a bootstrap distribution. So in our previous example of thinking about what is a bootstrap resample, we had a sample that had 4 observations. Typically, we're bootstrapping from samples that are large, that might have 100 or maybe even 1,000 observations or 10,000 observations in it. And the number of possible bootstrap resamples can get quite large really, really quickly. So if you just think about, let's say we have an original sample that has 20 values in it, and I'm going to pick a bootstrap resample. So the first thing I pick, I have 20 possibilities. Then the next number that I pick, I'm not saying I pick the number 20, but I have 20 things to choose for the next thing in my bootstrap resample, because each time we pick a value for our resample, we place it back. So if I start with 20 things, the first value I pick in my bootstrap resample, I have 1 out of 20 things to pick. I put that back. I have 1 out of 20 things to pick for my second. I do this over and over and over again. And the last 20th value that I pick, I can choose from 1 out of 20 things. So for each of the 20 things that I pick, I have a choice of 20. So altogether, that would mean we have a total number of bootstrap resamples that is at least or at most 20 to the 20th power. Okay, that is like a huge number, 10 to the 26, right? So that's like you're picturing a number that has 1 and then like 25 zeros after it. So this is huge. But the sample that we have, we want to consider samples that have the same values in them, even if the order is different, to be the same sample. So I don't care which number appears first, second, third, or fourth, just does that number occur in my sample? So if we ignore the order and we account for possible duplicate samples for an initial sample of 20 values, we have like 69 billion distinct bootstrap resamples that we can pick, right? Just for a sample of 20 values, we're talking about 69 billion samples that we would need to generate. So you can imagine it's really complicated to write code that's going to generate all 68,923,264,410 bootstrap resamples, making sure we get all of them exactly once and we don't mess up and skip one and get a duplicate of another. It's really complicated to write that code. It's going to take a really long time to run and execute that code, and it's not worth that waste of time and computational power. So in the end, all we're doing is we're trying to approximate a sampling distribution. So this is all based on randomness. This is all based on resampling, and we're just getting an approximation in the end. So we don't need to worry about being so accurate when we construct these bootstrap distributions. And instead, we can just use Monte Carlo methods, which are just computational algorithms that rely on repeated random sampling without worrying about whether we get every single possible sample exactly once. So instead of writing code that we're going to try and generate everything, all we're going to do is we're going to say, let's generate a lot of bootstrap resamples. And by default, we'll use 10 to the 5th power. We'll use 100,000 bootstrap resamples, no matter how big our original sample is. When n gets larger, then we might be able to construct a smaller number of resamples. But we'll see when we run these code cells that running a for loop 100,000 times is not going to take all that much time. So when we're doing bootstrapping, it's recommended that you use at least 10,000 bootstrap resamples when you're constructing your bootstrap distribution. The more resamples you construct, the better the bootstrap distribution is going to approximate the actual sampling distribution. So rather than us worry about generating every single possible bootstrap resample, we're just going to say we're going to do a lot of them. We're going to generate 100,000 random bootstrap resamples. And if we get some duplicates, no biggie. If we don't generate every single possible bootstrap resample, no big deal. We'll generate enough of them to get a good approximation for the sampling distribution. And so this is one example, bootstrapping, of a Monte Carlo method. And these Monte Carlo methods, they really came into being once we got more computational power. So they were aroused in the 1940s, while they were doing development of nuclear weapons at Los Alamos National Lab in New Mexico. And it's just called Monte Carlo after the casino in Monaco, which is because betting on things in casinos are pretty random, and this process is based on randomness. So that's why we call them Monte Carlo methods, though they have nothing to do with gambling or Monaco, besides the fact that there's randomness involved. So when we go ahead and implement our bootstrapping, again, we're just going to use Monte Carlo methods here, not worry too much about whether we've generated every single possible bootstrap resample.